let's review. Today we will be going over instantaneous rate of speed or instantaneous rate of change. So, last video we dealt with average rate of change, and that was dealing with graphs that had secant lines, or lines that connected 2 points of a graph. And for the average rate of change, we found the slope of that line right there. Now for instantaneous rate of change, rather than dealing with secant lines, we're going to be dealing with tangent lines. So we had a graph like that, and there is a point with the x coordinate of 2, and we drew a tangent line. But what we want to find is the rate of change at that single point. So how would we find the slope of a tangent if we only have one point? Basically what we do is, if you conceptualize this, you can have another point of 2 plus some unknown distance h. So now we have 2 plus h. And that will be our second point. But to make this even more accurate is if we have the limit as h goes to 0. Because then, technically, it's going to be 2 different points, but the second one's going to be so infinitesimally close to the first that it's going to be a really accurate representation of the slope at that given point on the graph. So, last video, we dealt with this equation. F of b minus f of a all over b minus a. We're going to be using that same equation now, but if we plug in what we just found, it's going to be f of 2 plus h, because that point is going to be acting as our b coordinate, minus f of 2 all over 2 plus h minus 2. So these now cancel out, and essentially you're going to get a new equation. You're going to recognize this real fast. It's just going to be f of a plus h minus f of a all over h. So there's 2 forms to this equation now. So an example problem would be if we had the equation y equals 16r squared. And then our t is going to be 3, or r, whatever. Using the f of a plus h minus f of a all over h, we're gonna make sure we retain what the function is. So in this case, it's going to be f of 3 plus h squared, because we can't forget that part of the function, and this will be f of 3 squared all over h. So if we plug in the rest of the function, it becomes 16 3 plus h squared minus 16 3 squared all over h. once you do the math, you're going to get 144 plus 96h plus h squared. I mean, you're just foiling it. There's nothing too complex. And minus 144 over h. Well, the 144's cancel out, and you're left with 96h plus h squared over h. And this easily, hopefully you can see this, you can factor out the h becomes 96 plus h, and then these h's cancel. And remembering the limits h approaches 0. So what that means is this cancels. Your answer is going to be 96. That's going to be the instantaneous rate of change at this single point. So yeah, that's basically the gist of it. It's not too complex of a concept to grasp. And this is a very basics because this really begins your journey into derivatives. As you dive more into limits, using these equations, it's all going to reoccur later on in calculus. So yeah, hopefully you enjoyed the video. Hopefully I was of help to you. Please like, subscribe, comment, do whatever.